Hello everyone, welcome to our channel. So in today's video, I'll be showing you how to perform a static code analysis for your Kubernetes manifest file using a tool called kubeLinter. So kubeLinter is a tool that helps you to identify configuration issues in your manifest file and then enforce best practice depending on your configuration. So you can put up a configuration that allow you to continue on error, and then you can also set it non-true when so that the pipeline will not continue on error. That is enforcing you to make the configuration change to correct the errors you have so that you follow best practice before deploying to your respective environment. So on my screen, you can see already I have a repository kubeLinter Kubernetes. So I have two file structures here. One is to deploy this using a Helm chart, and the second is to deploy this using a Kubernetes manifest file. So digging deep into that, we have on my Helm chart, we have the test, then we have the deployment.yaml. So this will just pull a Docker image directly from Docker Hub and then deploy this to your Kubernetes cluster. But for the purpose of this video, our focus will be on the functions of kubeLinter, on how kubeLinter can help you enforce best practices before your deployment. So the second file structure here after the Helm chart is the Kubernetes manifest file, so which will have pod.yaml. So during the deployment, the kubeLinter will run through all these manifest files and then detect configuration issues and then give you some errors and few pointers on how you can make those corrections to implement that following best practice. So we have our pipeline file which we'll be using to deploy this. So within this pipeline file, just a quick run through to this, we have the trigger, which is the main branch. Once the code is pushed to this main branch, it will automatically trigger the pipeline to run. And then we have our variables. So the two major variables we just have is the directory structure. We have YAML folder, which is referencing the four working directory and this particular folder, which is the Kubernetes YAML sample, which is this. And then the second here is the default working directory and the Helm chart sample, which is the directory here for the Helm chart. Then we have our pool image. If you check our channel, you see that we have already done a video on how you can create your self-hosted agent or managed DevOps agent. So in this video, we are using Azure agent, so Azure pipeline agent, which is a default agent provisioned and managed by Microsoft. So you can choose an image of your choice, either Windows or Linux or Mac OS. For the purpose of this, we are using Ubuntu latest. So two steps basically we are going to run on this is first is to run the kubeLinter on the uh, Kubernetes manifest file, and the second to run the same kubeLinter on the Helm chart. So this command basically, so here you see a Docker run on this folder. We have declared this YAML folder as a variable here, which I've explained. Then run this on any file that has this extension YAML in it. So which is the Kubernetes manifest file, as you can see here. So you have a stock rocks kubeLinter, which is this. So the purpose of this is to specify the Docker image for the kubeLinter. So this specifies the Docker image for the kubeLinter, and then this length command runs the kubeLinter on the YAML file in this directory. So which after running on the YAML file in this directory, so it will be able to identify every configuration issues and then enforce you to implement that using best practice. So this is just a brief explanation of that. It will run this static kubeLinter code analysis for Kubernetes YAML manifest file. and then detect any configuration changes or configuration issues. So the second script is to run this to identify the Docker image and then lint it. Linting is to run the static code analysis on the Helm chart and then identify any changes. So you can see here, continue on error true, continue on error true, because this is just a demo or a test environment. So if you are working on a real life environment, the continue on error should be false so that there will be no deployment if the best practice is not being implemented or if any of the steps are failing is failing. So what you do here is implement this to false so that if any of the step is failing, then it will not pass. You'll be able to go back, check your configuration, and then modify that to follow best practice before deployment. So let's go ahead and trigger our pipeline with this, and then you see how it works. Okay, good. This is a kubeLinter. I'm running this pipeline again. Let's just give it a few seconds or a minute and it will run, and then I'll give you explanation of what that means. Then we'll go back, modify the code and run the pipeline again, and you see the changes. So good. You see on the kubeLinter for the Kubernetes manifest file is failing. That for the Helm chart is also failing. So let's take a look at that, and you see you have some error message that is okay. Yes, on this you see you have two major error messages which are pointing to. The first one is that this container demo does not have a read-only root file system. So a little pointer to that is no read-only this, and then remediation is to set a read-only to true. So you see that the error message at times gives you a pointer to what modification you are going to do. So the second error message is saying that has memory limit 0. So we need to basically go and set a memory limit. So has memory limit 0, remediation, set memory limit. Set memory limit for your container base. Okay, let's go back to our repository and then do that modification and come back and run the pipeline again and see what that means. Okay, good. On this, so the first error message is showing that we have to set on the security contents, we have to set the read-only root file to true. So we comment this, we uncomment this out. And then the second error message is saying that we should put a limit, a memory limit. So we will comment this also. So show also if there are other configuration changes in this, the error message will give you a pointer to it, and then you have to implement it. So we do a commit now, set memory limit and read only. Okay, let's go back to the pipeline. You see it's already triggered because we committed directly to a main branch. So let's see how this plays out. Good. You can see by implementing those corrections, we have passed this stage. So it's showing no lint errors. So meaning our configuration is following best practice and we can deploy. So on the second stage, linting on Kubernetes Helm chart. So this Helm chart now, we're having series of errors here. 2, 3, 4, 5, 6, 7. We have about 7 errors. So by taking a deep look into that, some are pointing to deployment.yaml file, while some to test connection.yaml file. So we have to navigate into these individual files to correct the error messages. Then let's go and see the detailed error message. So this is saying the helm chart does not have a read-only root file system. Also, is not set to run as non-root. So which normally is supposed to be run as user, not as non-root. Yeah, we have to run this set run as user to non-root user, so that you don't have to implement this using a root user. So, and run as non-root to true. This second error is set CPU request for your container based on its requirements. The second is set memory limit, and then just the rest. So set only root files to this, set run as user to non-zero number, and non-root user to true. So the error message using kubeLinter mostly gives you a pointer to configuration changes that you have to make on your environment. So we go into this. Then the first is on deployment. We have test.connection, which the error message pointed out here, test.connection. So you have to test the connection. What's the error message here? We have does not have a read-only root, run as non-root user, and the rest. I already have that figured out. So here we have read-only root to true, run as non-root user to true also. And then run as user should have a value instead of 0. So we uncomment this. Then the second error message say that we have to set a memory limit. Then we uncomment this. So we'll commit. Once we commit, before we come to this, you see that some error message will clear then pending this. So we'll commit. Let's just forget some time so that this video doesn't take much time. So we'll go back here, see that the pipeline is already running. This will pass because we've already corrected that. Then this will fail, but the error message will be minimal. Okay, good. You see, initially we had 7 error messages, but now we have 4. So all the errors that reference test.yaml, we have cleared them. So we have this pending deployment.yaml. So we go to deployment.yaml to make the corrections. On deployment.yaml, we already have that figured out. Set this to true, and first as non-root user, and set run as user to a value. So we'll comment this. Set a memory limit also to this. We uncomment this. And then once we commit, so any other configuration changes or error that you have here, kubeLinter will be able to point that out and then give you a pointer message. Though at times the message might be vague, but you can check a more detailed log and then troubleshoot that. So we check on the pipeline again, it's already triggered. Then we go ahead to confirm if it will be good. So now we have no error, so no length errors. So using kubeLinter or any other static code analysis tool on your Kubernetes manifest file is a very good implementation, because it will give you a pointer to whether you are following best practice or not, and then 1 or 2 messages on how you can go about resolving the issue. So if you found this interesting, don't forget to like and put your comment on the comment section below. And also, if you have any questions or need a more detailed examples, just drop it on the comment section, and we'll do our best to respond to you as soon as possible. Also, if you have any topic of choice that you want us to treat on our next video, don't hesitate to drop that on the comment section. As we promised, we're going to give you a walkthrough on every aspect of Azure DevOps interface. Stay tuned and see you on our next video. Thank you.